Now, in this section, we're going to talk about what are comparison operators and logical operators in Python. We might as well have comparison, op, and logical in Python. That means that we're going to talk about what are comparison operators and then obviously that means that total comparison operators and then comparison operators in Python and then using comparison operators. And then what are logical operators? And then at the same time, we're going to mention that that is the bit of combining comparison. And then obviously, finally the common. And best practices. All right, let's talk about decision making. Imagine you're at a theme park and there's a ride with this rule. You must be at least 12 years old and taller than 4 feet to ride. This is exactly how Python makes decisions with comparison operators and logical operators. Let's break it down. So let's start with what are comparison operators. Now, comparison operators lets Python ask questions and compare values. Say, for example, is one number bigger than the other? Are two values equal? So let's see an example. Maybe say, for instance, for a case, we could say maybe say is 5 equals to 5, right? So that's what you're asking with the operator, that is. And in such a case, we could go ahead and just have this displayed. So that means that we'd have something like that. And then in that case, then what we're looking at is getting the output. So for a case, we're going to say Python, and then there should be comparison. And then get the output as true. So it tells us like, hey, 5 equals to 5, that's true. So that's the output that we're getting. So obviously at the same time, that means that we can get to display something like is 10 greater than 2. And then that should give us an output as 2. Bye-bye. In this case, confirm that 10 is greater than 2. You'd say that comparison operators allow you to compare two elements, right? To each other. You'll also notice that our outputs here, we're getting them as true. And then for the second one too, we're getting it as true, right? So remember, in this case, then that means that it returns a Boolean value, either true or false, depending on what the statement is. In our case, obviously, if we change this, we're gonna get false, right? So if you say 10 is less than, then if you run that, then we're gonna get false in our case, right? So that's something to note. Now, we should also identify the operators that we're considering. So for case, we have the equal, less than, and then we have greater than, and then we have also a not equals to, like so, and so on and so forth, right? Now, we could also consider this as using comparison operators, right? So in Python, obviously. So there will be number 2 using comparison operators. In this case, what you're trying to do is, again, checking if the values are equal, and then checking if one value is greater than the other. That's how it go about it for the most part. Now, the other thing to consider is logical operators. And then now we're going to talk about what are logical operators in this case. And essentially, comparison operators help us check one condition, right? So true or false. But what if we need multiple conditions? That's where logical operators come in. They allow us to combine multiple comparison operators. Combine multiple comparison operators, right? So that's the beauty. Now, that means that if we want to look at the examples, there'll be something like and or not, etc. Right? So for the most part, though, we're going to be using and or not in this case. Okay, let's fix these typos. This should be combine, comparison. Okay. Now, with the operators that you're looking at, there's and or not, right? And obviously, with the and operator, you'd always consider it as both conditions must be true. So for it to be true, obviously. And then for or, then what it mentioned is at least one condition must be true. For it to be true, that is. I'm gonna see how that looks like. And then at the same time, if you talk about say not, then it just reverses the result. If something was say false, it's gonna reverse that to true. We're gonna see how that looks like too. So those are the kind of types of the comparison operators that we're gonna use. And at this point, let's talk about now combining comparison operators and logical operators. So let's have that one here and work around that. Now let's combine them to make powerful conditions. So let's say talk about maybe example that we mentioned earlier, backgrade eligibility. And for our case, we're gonna say, hey, age equals to maybe something like 15, and then height equals to something like 4.7, and then now we're gonna have our variable that is can ride or can someone ride, and we're gonna now look at say the specific value. So we're gonna say if age is greater than or equals to 12. Remember, those are kind of the condition that we had, and if height is greater than 4. So we're gonna print someone can ride. So that means that it's gonna look at hey, is the age. The age, we have our age here as 15. Is the age greater than or equals to 12? And then, so for case, if we just try to check that out from that, so our age is 15, that would mean that this will be true. And then, and height is greater than 4, that will be true. And then remember, we're using and, right? And in using and, we mentioned that both conditions must be true for it to evaluate to true. So in this case, we should be able to expect that our value will be true. So we're going to go ahead and run that, and then we get our value as true. So in this case, then that means that the person can ride since both conditions evaluated to true. Another example would be checking login credentials. Where in this case, we're considering the username. Let's say you're signing in to our website, and then you have admin, and then your password. Obviously, this wouldn't be an advisable password to use, but yeah, let's have 1, 2, 3, 4. And then now, what we're trying to check is the person is a user, a valid user. So we're gonna have something like so. Then we're gonna say, hey, if username equals to, you're gonna confirm the username first. If username equals to admin, then and password is equals to 1, 2, 3, 4. So in this case, we're gonna print the output of is valid user, and then in our case we should be able to get true since both values are true. Now, if you change the value, maybe have it like so, and then try run this, we're gonna see that we have false, given that this value doesn't correspond to user's password in this case. So that's how we check that. And if you'd prefer, we could make this a bit interesting by introducing to input function. So obviously for this case, as the name gives away, allows the user to input some values off of the terminal. So we're gonna see how that works. So in this case, so instead of having admin like so, we're gonna say input, and then we're gonna say something like enter your username, like so, and then that will be similar to this. So enter your password, right? And then like so. So obviously now if we run this, I'm gonna ask enter your username, and then I'm gonna say admin. Then we could have 1, 2, 3, 4. Then tells you like, hey, is it a valid user? That's false, right? This person valid user, something like that. And then now yes. So we're gonna have comma there. So it's gonna tell you like, hey, sometimes it might help you with the errors. Perhaps you forgot a comma. That's what we have there. Now, so for instance, for case, you can say we can have the same values, and then admin, and then that will be 1, 2, 4. That's a valid person. Then it's gonna tell you true. Yeah, that's how valid user. So as long as the values correspond, right? So remember, you can also have these values. Maybe you can have stored values, stored maybe user, stored password, pass, like so. And then for this case, you're saying, hey, for the stored password that you have, maybe it's 1, 2, 3, 4, 5. Then for stored value that you already have, that will be admin. So in this case, instead of that, we're gonna have something like stored pass, and then here instead of admin like so, you're gonna have stored user, stored user like so. Now that means that again, if you get to run this, we asked about to enter your username. So for case you can say admin, and then enter your password too. So we're gonna say 1, 2, 3, 4, 5, and then true. We're gonna say like, hey, that's true. Awesome. So that's how you'd walk around, say, both comparison operators and logical operators, because you can see that comparison operators, the equal signs, and then the logical operators, even to kind of make some checks off of the database. So in this case, we'll be considering like something like maybe you've stored your values in a database, and then you're trying to confirm your database and the kind of the inputs of the user. And yeah, so we've also seen like, hey, you can use an input function for the same. The good thing about the input function is going to output values as a string, right? So it's going to consider your values as a string. So in such a case that if you have 1, 2, 1, 2, like so, right? And not really. So we could just say something like, if you have maybe if you provide your values, and then say print type of values. So we could say type of password, type, right? That should be data type. Then have password. Then now if you run that, then that means that you have our user admin and then password 1, 2, 5. Then it's gonna tell you, hey, type of password data type. Oh, should my bad, I should have it wrapped using type like so. So that yeah, that is captured. So if you run that and then have admin 1, 2, 3, 4, 5, and then it's gonna tell you like, hey, there's a string data type, right? So that means that at any point you provide a value to your input function, that will be a string data type. So in our case, that means that to have this kind of how you see this, we change that like so, and then run it again, and then have admin, and then have 1, 2, 3, 4, 5. Then you're gonna say like is the person a valid user? False, but you gave the same values. That means that this is an integer, and what you have here as a type is string type. So we're gonna change that if we need it to conform to our stored password. So and then say input, right? So we're gonna just wrap it like so. Not input, sorry. So that will be integer. So to change it to an integer data type so that you can easily it can easily compare to our stored password. So could run that again and have admin, and then 1, 2, 3, 4, 5. So and then it's gonna tell you like, hey, now our data type has a type of integer, and now that's true given that you have this one as an integer, and then you've changed this as an integer data type. Awesome. Now in this case, we've really considered the AND logical operator, as you can see here, and also here, right? So the AND logical operator, we can use that. And again, just emphasizing on this. So when both conditions are true, then it will be able to evaluate true. Otherwise, it's going to be false, right? As we saw, right? So if you have only one of the values being true, then and the other one false, then it's going to evaluate to false mostly. And if false, evaluate to false. Now, let's look at, say, an example of OR, right? To help us allow multiple conditions, right? So in this case, then we could say a scenario where you have a ticket for maybe a particular party or something, and then maybe say someone has a ticket, and then also is it a VIP ticket? So and then maybe false. Maybe you have just a kind of a normal ticket, not a VIP one, and then such you can have a variable can enter. Someone can enter using those, considering those conditions. So we're gonna say has ticket or is VIP. So then we want to print out, maybe say something like this the person enter the party, and then we're gonna have like, hey, can enter. So right. And then now this time if you run this, okay, so it's gonna ask for the input. Remember, it's gonna first review the kind of this codes first before what he had. You could just as well just comment this one so that we don't run into that. Let's just comment this for now. I'm gonna come back to it. Then so run it again. So it's gonna tell like, hey, can the person enter the party? True. Obviously, now we're considering the use of or, and what he mentioned with or is if at least one of condition is true, then it should be able to evaluate it true. So in this case, what you're saying is has ticket is true. So that means that it's going to evaluate true, right? So let's say if this person doesn't have a ticket or is not VIP, then if you run this, then it's going to tell you like, hey, false. This person can enter because isn't VIP or anything, right? So we could also have vice versa, whereby you have this one as true, right? Just confirm everything, and then has a ticket false. Hey, you VIP. If you're VIP, you get a VIP ticket. So and then has a ticket, so that will be the normal ticket. You don't have it, but you're VIP. Then this person, then we're gonna see if this person can still enter, right? And yeah, that's true. Like this person can enter. Remember, as long as there's true between the comparisons, then that should be able to evaluate true. That is. Now let's consider not to reverse a condition, right? So that will look something like maybe say it's raining, and then maybe you have true. So if you go ahead, you could also to reverse it, just start with not, and then it's raining, right? And then yeah, so if you wanna get an output of this, you're gonna say something like that. And then we're gonna say maybe is it raining? Um, like so. And then now, if you run this, obviously we need a comma there. Then if you run this, you'll be getting our output like, hey, that's false. Not it reverses everything. So if you have false now, then it should be the opposite, right? So that's how you can easily understand that bit, right? So okay, it is true. Is it raining? True. Now there's something to note that for instance, if you have an evaluation of maybe you could have x as 5, y equals to 10, and then z equals to 15, right? Like so. Now, in such a case, then you might want to compare all these values. Let's see an example of how we do that. We could say maybe if x is greater than 2 and y is less than 20 and maybe half, or in this case, z equals to maybe 15. So those will be our conditions that we're looking at. Now, in such a case, then you could have something like this printed out, and then get to evaluate that, and then we get true, right? For our case, we get that that's true. So that means that in this case, if we break down this, that will be so x is less than 2, that's false, and then y is less than 20, that's true. Oh, sorry, x is greater than 2, not less than, so that will be true. That will be true. And then this one, we're looking at that like so. So yeah, we're looking at that like so. And then now in our case, remember we're considering the comparisons here. That's z equals to 15, which for case z is 15. So that means that here is also true. So in our case then, we're evaluating that to true, right? So we're evaluating everything to true given out there. So another thing to consider is that if you have such kind of comparisons, you're using your logical operators, you could consider using the parentheses, right? So if you say something having like so, maybe whereby you're considering this both together, and then after that you have or z equals to 15. And obviously for a case, then that means that we just get both the same output, right? Like so. Or the good thing is, if maybe you say you change this to like so, then remember here we're considering or, and then in this case we're considering this part with this part that is within the parentheses. So that means I should be able to evaluate the true. We're gonna get an error, need valid argument. Okay, let's see how that, why we have that. Oh, invalid argument. So yeah, that would be maybe adding another parenthesis here. That's a common mistake, if anything. So adding parentheses, then having that one. It's like the error is no longer, I'll say, on the code, but the added backslash, right? So we just want to remove that, so, and then run that. Then we should be able to get our value. Yeah, so remember you could have, say, the parentheses, so that at least if anything, because for instance, for case here, what's happening here is we have this as false, this side, and yeah, still evaluates to true, considering that we now have this inside a parenthesis, so have them together. On this other side, also, we're considering having that alone, that is in the parenthesis, that separates the different, say, logical operators that we have on both sides. On one side, that is obviously the and, so combines everything. Pretty clear, right? So using parentheses makes complex conditions easier to read and then easier to navigate through. Awesome. So that's comparison logical operators. So just a quick recap. We've discussed comparison operators. What are comparison operators? And obviously check mostly helps us check if values are equal, greater, or smaller than. And then obviously we talked about now logical operators, and then a bit about combining multiple comparison operators together. So you're going to use and, or, uh, not, etc. For the same. And then now we can see the kind of what and helps with. That is, both conditions must be true for it to evaluate to true. And then something like or, at least one condition should be true for it to evaluate to true. And then not only, the work mostly is to reverse the results. And that's how it work around it. And then obviously talked about combining both of them, and then so how you can combine this. And then finally now talked about say using the parenthesis bit to be able to make your conditions easier to read. Now that you know how Python makes decisions, get ready for the next level, that is the conditional statements. We'll use if, elif, and else to make Python even smarter and easily navigate through several decisions. Now, in this section, we're going to talk about branching in Python. In that case, we're talking about is how Python can help you make decisions using if-else statements. So that would be if, elif, else statements. So we're gonna comprehensively talk about branching in Python, that is making decisions, and kind of walk around also the real world analogies or implementations on the same. Now that said, we'll be talking about what is branching, the if statements, the else statements, the elif statements, and chaining both of them together. So that means that we have what is branching, and then obviously we're going to close with the nested conditions, and then kind of see a real world implementation of the same and how to go about it. So when you're considering all these particulars, then we're going to see at this point, in terms of what is branching, we're going to talk about why we need it, and then the if statement, making simple decisions, and then the else statement, what if the conditions aren't met, then that's where the else statement comes in. And then the elif should be able to help handle chains of decisions. And then now we can chain or combine if, elif, and else statements to come up with complex decision trees. And also now nested conditions whereby one decisions depend on the other. So we're going to look at all this. First off, we can start with the branching. Now imagine you're at a park and you want to go on a roller coaster. There's a sign that says you must be at least 12 years old and taller than 4 feet to ride. How does the operator decide who can ride? They check your age and your height. Simply put, branching is Python's way of making decisions. It allows the program to execute different code based on specific conditions. So think of it like a yes or no situation. If something is true, do this, others do that. Now, let's look at a basic syntax of branching. You'd have your if and then condition, the particular condition, and then if the condition is true, then the code below that condition executes. Now, there's elif and then another condition. If maybe the above condition is false, then that's when you'd have it branch to the next elif statement. Now the condition executes if the previous one is false. And then if both of these are false, then that's when it's get to execute the else statement. This is the basic syntax of the branching, and we're going to break it down. So let's break it down step by step and see how they look like. Now, let's start with the if statement. So in this case, it should help us make simple decision, right? It's the most basic decision making in Python. So that will look something like this. So for instance, if you have one number equals to 34, variable number, and then the value is 34, and then we want to consider say using if. So again, the if statement structure will be something like if condition evaluates to true, then it should be able to print out statement 1, then event statement 2, like so. So that's how we look at it in terms of the structure. So that means that if it evaluates to true, then you should have all this kind of be able to run that. So let's have it here. Now, say for instance, we have number equals to 34. Then now we want to use if. So we're going to say if the number, and then we can have modulus 2 equals to 0. And your guess is just as right. So if you're doing modulus 2 equals to 0, then we're checking for even numbers. So that means that given the use of modulus, as we discussed before, the modulus should help you get a remainder after doing a division. So for instance, for case, we're going to do 34 divided by 2. And then if we don't have a remainder, that is, if you have a 0, then that means that we can consider this as an even numbers. The opposite should tell us that this is an odd number. So that's what we're considering. Now we're going to say something like, hey, print the number is even in our case, right? So that means that this part, this is a statement that we are having under the condition that we're trying to consider. And this is now, we have the if keyword, then we have our condition here, that is number modulus 2 equals to 0. So we're going to right away just run this. Let's run it. That will be Python. And then we get the number is even, right? So that means that it's going to look at the condition. Here, this is our condition, number modulus 2 equals to 0. So if modulus 2 doesn't have a remainder, then we can consider it as an even. Now, let's change that to 33. And then obviously in this case, what you're considering is we're going to have 33 divided by 2, we're going to have a remainder 1. That means that this part, this side, that is, we're getting a remainder of 1, which is not equal to 0. Obviously, in that case, then we can guess what we'll be getting. We'll be getting output of none because that's false. It's not going to give us any output in this case. And we're going to expound on that. But in this case, we could also consider another example. Maybe say we have an example like age equals to 18, right? And then we have if age is greater than or equals to 18. So we're going to say you can buy a ticket for a rated movie if the person has an age greater than or equals to 18. So that's what we're trying to consider. In this case, then, if you go ahead and try run that, obviously, they'll tell you like, hey, you can buy a ticket for an R-rated movie. And obviously, if now we have maybe something like 17, which is below 18, then won't get an output. That means that this condition evaluates to false in this case. Now, I'm sure you can note the 4 spaces here, right? So there's this space here, right? And also at the same time, if we consider this part here, we have this space, right? The spaces inform Python that the statements are associated with the if statement above, right? So the if statement that we have, this technique of structuring code by adding spaces is called indentation. So whereby you kind of have indent your code first, right? So let's see if you don't have the indentation, what will happen, right? So run that. And it's going to tell you, hey, expected an indented block after if statement on line 36. It tells you like, hey, on line 36, you want to have indentation. So then that means that you're going to have the bit of the indentation. And something also to get here is Python relies heavily on indentation to define the code structure. So this makes Python code easy to read and understand. You can run into problems if you don't use indentation properly. I can see in the moment. That means that you want to indent your code by placing the cursor at the start of the line and pressing the tab key like so. So that should indent it. Pressing the tab key again should move it another 4 spaces, right? Or you could use your space key, right? So that would be 1, 2, 3, 4, right? So either a tab to pick up the 4 spaces or the space bar to be able to also pick up the 4 spaces. Now, also pressing Shift Tab to return that, or maybe say, for instance, you had something like that, you can just press Shift Tab to reduce, say, the indentation by 4 spaces. Now, let's look at the else statement. So that would be the else statement here. And in else statement, you're handling the otherwise case. So let's have it here. Great. So let's come back to this, right? So remember, for num here that we did consider, we were getting that's not an even number, so could just pick this here, then have it here, and then introduce the otherwise case. Whereby, so for instance, for case the number is even, and then not even, the program moves to else and prints out the number is odd. So that's what you're trying to consider. I'm gonna say print, and then says the number is odd, like so. So in our case, that means that if we run this, we should be able to get the otherwise case. So tells us like, hey, the number is odd. That means that, yeah. So if the condition is false at this point, else statement should be able to catch that and then be able to print it out for us. Now let's take an example of maybe say checking a name inside a tuple. In this case, we're gonna initialize our variable, that is the three musketeers, and then equals. Then for case, we're gonna have maybe something like Athos, Porthos, Aramis, like so. And then so we're gonna have our candidate that will be checking if existing in the three musketeers variable that I've created. So for case, we're gonna have D'Artagnan. So that will be and then we're gonna have now if candidate in the three musketeers, we're gonna print something like candidate is a musketeer. So we're gonna have it like so. Else should be able to display that candidate is not a musketeer. Now, just run that, and what you can see is since D'Artagnan is not in the tuple, the else statement runs, and we get D'Artagnan is not a musketeer, like so. Now, let's move to the elif statement. And in this case, as we mentioned earlier, it's gonna handle chains of conditions together. So, and then consider it here. So that will be the elif statement, that is number 4 in this case. And then we're gonna say maybe handling chains of decisions. So for this part as well, you wanna consider when you have more than 2 possibilities, then that's where now the elif statement comes in. Let's have our days of the week, meaning maybe today equals 2, and then have maybe something like today is Monday, then have our conditions, like if today is equals to Sunday, and say like today is the day of the moon, right? Then have a leaf here. Let's say today equals Monday. Then we want to display that today is the day of the moon. Okay, now that I recognize this, they can be both moon. This will be the day of the sun, and then the day of the moon. So that's what we consider. Now we can have another elif, then just elif today equals to something like Tuesday. Then we can say today is the day of Tia, God of War. So then now we can say else print or display it's just another day. So that means that in our case, we're going to be inserting our condition from here. Then that means that we're going to try check if Sunday is similar to Monday. And then if it's not, then that means that it's going to skip the statement and then branch then the next statement and the condition. So for our case, we're considering today equals to Monday, and that should be equals to similar to what we're trying to check there. Then obviously, this is what we're going to get printed out in this sense. Then that means that it's going to stop at this. That's also something to note. So whereby Python stops checking after the first true condition. So this is the condition that you get, it will be true. Then that means that it's going to stop at this statement, that is, then leave out the other values. Now, if you go ahead and run it, it should be kind of what we just envisioned, that is today is the day of the moon, given that this condition here evaluates to true. Now, let's check another interesting example whereby we're checking divisibility. Test. So in this case, then that means that we have number equals to maybe 15. Then we're saying if number modulus 2 equals to 0, then it should be able to print in our case as that's divisible by 2. Then else, or rather elif, number modulus 3 equals to 0, then should be able to print divisible by 3. And then there is another elif, number modulus 5 equals to 0, then print divisible by 5. There's something interesting about this, because now if you have 5 and we want to pass it through say our branching or the if elif else statements, so we're going to start at this point, right? So checking if num modulus 2 equals to 0. Obviously for our case, we're going to get that is 15 modulus 2, we're going to get 1 because we have a remainder, and then that means that it's going to skip this part, right? And then I should be able to move to the next part, that is num modulus 3 equals to 0. So obviously that will be 15 divided by, or modulus 3 you won't have a remainder. That is, if anything, you just have the remainder as 0. So in such a case, then, we're going to display divisible by 3. Now, something also to note is that we've started with num. We're kind of considering that num. Obviously, for this case, modulus, we're going to get a remainder of 1. And in this case, that means that it won't be able to print out its statement. So I'm going to skip that. And then in skipping that, it's going to move to the next one. Then it not num modulus 3, which equals to 0. It should just print out divisible by 3. And then in this case, then what you're getting is should be able to stop at this. So remember what you mentioned just a few minutes ago, whereby Python stops checking after the first true condition. So that means that in this case, I should be able to stop at this point, even when we have another condition here, which is true, right? This one is also true, but it's going to stop at this point and then leave out the conditions below it. Okay, so for case, it's going to say divisible by 3. So that means that it stops at that point. Now, what you can see is even though 15 is divisible by both 3 and 5, Python only prints divisible by 3 because it stops after the first true condition. Another interesting question is that if, for instance, you want to check both multiple conditions, that is, how will you do that? And that's where now we're going to use to check multiple conditions. Let's consider checking multiple conditions. Using if. So that will look something like this. So we could as well just copy all of this. And then remember what we mentioned earlier, like, hey, we have two conditions that evaluates to true. That is this condition. And then also at the same time, these conditions. So both of these two conditions evaluates to true. And in a scenario whereby we don't want to print both of them, then we can as well just use if, yeah, then that should be able to output both of the values. So for a case, we just comment it, that's clear. So obviously, you can run that, then we'll be able to say like, hey, divisible by 3, divisible by 4. So that's something to consider too, if you don't want to output every condition that is true. Let's look at our fifth pointer. That will be nested conditions, right? Obviously, we've talked about this by chaining both of if, elif, and else statement together. But for case, let's talk about now the nested conditions. So that will be 5. And then now, with the nested conditions, kind of the main question is, what if we need to check one condition instead of another one? So kind of that's how we come up with the bit of the nesting. So in our case, I'm gonna just come back to one of the example that we introduced. Says this example here. Then just use that example. And then in this case, we're gonna check for age and height for this. We're gonna say age equals to something like 14. Then we're gonna say maybe height. But we had this example before, but we'll use this. Could say if age is greater than or equals to 12. Then we're gonna say inside that. So we have the operand if statement, and then we're gonna have the nested if statement. So if height is greater than 4, then you should be able to print out, that is, you can write and then else you should be able to print out you need to be taller, right? Else here we're gonna say print you need to be older. So let's just understand this part. Now, breaking this down, we understand that we're going to be starting with a first condition here. That is, age is greater than or equals to 12. And then if this evaluates to true, which it does, because we have 14, so which is greater than 12, it's going to just get into the values or statements under the parent if. So for our case, it's gonna go to this part, then check if height is greater than 4. If it's true, it's gonna print out now. You can ride, and then now that means that it's gonna stop at this point, right? And then print that out. Okay. Now the other scenario is that if, for instance, we have this as maybe 3, then that means that we're gonna have it skip this, and then print you need to be taller, right? Only, right? So that's something to note. So remember, as long as this evaluates to true, or the condition here evaluates to true, everything is gonna play around the nested if, that is, and then print out the appropriate one. If it's not, then it's gonna just print out the otherwise, that is, you need to be taller right away. In that case, we can see this in action. Then just go ahead to run this. Obviously, for case here, it's gonna just print out. You can write. We did see illustratively. So obviously, you can write given that this condition is true, and then it's gonna get to the nested if, and then check the first condition there for the nested if, and then print out. You can write. Now that means that, for instance, if we change that to maybe something like 4 or 3, which is below 4, then we should expect that the value to be, you need to be taller, right? Because that means that although the condition is evaluated to true, it's going to get to this part and then obviously start with the nested if and then the condition, and then find that, hey, the condition doesn't evaluate to true, it evaluates to false, and then that means that it's going to just take the else route to be able to print out, you need to be taller. Now, let's look at the other scenario whereby maybe if you have, say, a lower edge, then let's see where it's going to stop or how it's going to do the branching, as we did see. So it's going to just right away tell you need to be older. That means that it's going to skip all this, that evaluates to false. And then obviously, if it skips that, it skips everything under that if statement. Then prints out you need to be taller. Also, you want to notice how the print statements are indented by 4 spaces. So for instance, for case here, you can see those are 4 spaces. Those are 8 spaces, sorry, compared to now the 4 spaces that you have for the if statement. Obviously, for this means that you want to indent the print further to just confirm that, hey, it's under the nested if. Yeah, so that's something to note too. Also, you can see that the nested if statements are often confusing to read and also to kind of work around. So it's always good to avoid nesting whenever possible, or limit to 1 level or 2 levels. We could look at even a 2-level one and then see how that will turn out, right? So for instance, for case, that means that we're going to have another, say, statement here, say if, maybe for this case, you're considering the height. So we could just try to consider if maybe someone has either the real height or not, right? Now, in our second level of nesting, then we can have something like if age is greater than 18, then we can have print you qualify for a AP pass, right? Else, one should just print enjoy your ride in this case, right? Now, in this case, we can see that we have a second block here. That is if the checks qualification for a VIP pass. That means that we have a third if here, whereby we're checking for qualification for VIP pass. So we have our first if, checking for age, and then if someone is either 12 years old or older. And then the second if, that is if someone has a height of over 4 feet. And then the third if checks if the age is 18, be able to offer the person a VIP pass. And that's how we go about kind of creating all these levels. and working around the nesting. That obviously, as you have many nested if, then obviously that's gonna be a little bit confusing. But for case, we could try consider this and then see how this looks like. So we could say maybe, hey, if height equals to maybe something like 4 or 5 or something like that, and then we could say like, hey, maybe this person is 20. Let's see what we get as our output. So you can tell us like, hey, you can ride and then qualify for VIP pass, right? So it tells you like you can ride and then qualify for VIP pass. And let's say if you don't qualify for VIP pass, what happens? So that means that we could just return that as 14. Then if you run that, we'll just tell you, hey, enjoy your ride. You can ride, enjoy your ride, right? And that stops at that point here. So that's how to be able to navigate all through the nested conditions, then walk through all the, say, having one condition under the other, at the next, and the next that is. So you can have as many blocks as possible in terms of adding other, say, functionalities with your if statements. Now, let's do a recap to check what we did learn. So we've talked about if statements, else statements, and elif statements and nested conditions. So that means that we started with branching and kind of how branching should help us walk around decision making, that is. And then we did see the structure of the same, but most importantly, obviously, started off with the if statement, which should help us make some decisions. So obviously, just executes when the code is true. And then we introduced the else statements, which handles the otherwise case by executes when the condition is false for the if statement, that is, or elif statements. And then we introduce the elif statements, which can handle chains of decisions, whereby we have multiple conditions together, or the chains of decisions. So, for instance, we have this, and then we have also this to consider, right? So, and then we can have as many as possible, kind of multiple conditions that we're considering or decisions. We also talked about now the nested conditions, and then so how like to get around nested conditions if inside another if or complex decision. In this case, that's what we're talking about. In such a case, then we saw how kind of we can have as many levels as possible for the different if statements or the different, say, nested ifs that we're having in this implementation. Awesome. So now that you know how Python makes decision, let's take it up a notch. Next, we'll apply this knowledge in real world scenario and see how kind of some of the implementation that we can work with using the if, elif, else statements. Okay. All right. Now that we understand how Python makes decisions, let's see it in action. So from building maybe a student grading system to a weather app, right? If else statements are everywhere, and in this section, we're going to build real world example using Python's decision making power. Now, if you think about it, all decisions we make on the daily, from choosing what to wear on the weather to checking your grades, Python helps automate all these decisions. That's what we're going to be looking at. At this point, we're going to just look at simplified version of these applications and then build up onto that on subsequent when after learning subsequent topics and now getting an understanding of other sophisticated concepts around Python. In that case, then we're going to start with the student grading system. So I'm going to rename my file here to student grading.py, then kind of our student grading system application in this case. So in this case, we're going to see how a teacher could calculate a grade off of your scores. And now we're going to write a program that takes a student's scores and assigns a particular grade. So first thing first, we're going to just start with mapping out how this application should behave. That should give us some direction into how this will play around. And that should give us kind of a prior understanding into what you'd need to have while implementing this. So that will look something like this. So for instance, for cars, we'd go ahead and ask for users input. So obviously for this input, what you're saying like, hey, that would be the grade in that case. And then after getting an input, we're gonna check if a user enters a value, maybe 90 in this case, then that means that we should be able to display a grade. Maybe for our case, we're gonna display grade A, and then that means that also we also have our elif enters a value 80. It should display B in this case, and obviously that means that that will follow suit for 70, 60, 40, and so on and so forth. Now we can have our else statement here. So the else statement will be maybe final grade. So we should be able to display a final grade here. Maybe F if someone scores maybe below 40 or below 60 or something. Now that we have kind of these details mapped out, so we can now kind of easily work on the specific code that is. So for our case here, ask for users input, we're gonna say, hey, that'll be score variable, or we could just start with the input and then say for our case, we're gonna say like, hey, enter your score, like so. And then we'll be expecting the person to enter the score. Then we're gonna have that as a score variable inside a score variable, that is. And also now after having that inside a score variable, then we're gonna check if the score is greater than or equals to 90, and then we should be able to display. We're gonna say the grade equals to a case that should be A, and then there should be A, that is in that case. So we could as well just remove display gray, and then now we can talk about elif now. So remember, the elif part should help in handling multiple conditions that we'll be looking at, and that's what we want to do now. So that will be score, that is if it's greater than or equals to 80. So then I want to display B. So for a case that will be grade equals to B, like so. And then so we could just remove the display here, have it like so. So now that means that we can continue on and have another elif. So the next elif will have something like if elif score is greater than or equals to 70, grade should be C, like so. And then another elif statement. So we're gonna have elif score is greater than or equals to 60. Then we're gonna have our grade as equals to now D. And then we could just stop at this point and then kind of have our else statement here captured. So we could say, hey, now else anything below that will be grade equals to F. Okay, so that's what we're considering. Now, if we have it like so, then we could go ahead and kind of see the output of this when we kind of provide the specific value that is. So that means you can also have this like so. And then we could just remove kind of now the extra comments that we have here, because now we've already mapped out. It has helped us create the program for case. Now that means that if we have an input, we could go ahead and run this and then see how when we provide an input, how this will turn around. So if we have student, and that should be grading .py. So it's gonna ask for a score, and then we could have 90, and then it's gonna tell you like, hey, we're getting an error, not supported between instances of string and integer. So what this means is that kind of what we talked about earlier about input functions. So with the input function, you'd expect the input function to provide you with string values. So those will be the string data types or string values. So in such a case, then that means that if you provide a integer value, it's going to be changed to a string. So in that case, then we want to wrap our string value with int so that it changes that to an integer data type. So this time, if we try run this again and then have maybe 90, then we get a value as enter your score, then we don't any grade evaluation. Oh, okay, because obviously we can go ahead and print that out. So we can say, hey, print, and then we can say your grade is, and then so provide the grade. So we can say that is the grade, like so. So since we're storing the grades as variables, that is. So obviously, if we provide 90, then this should be the variable that we're looking at, the updated variable. So obviously, it's going to stop at that point. So with that, then we want to run this again and then see the output. So we're going to say 90, then it tells us like your grade is A, right? And then that means that if you provide maybe a value like 30, it's going to tell you like, hey, your grade is F, right? Now, this is just an example of Python assigning the correct grade based on the score, just like a school report, that is. And in this case, then that means that we're just using the functionality of if-else statements, if-else statements to be able to have this featured and at the same time kind of help with the decision making from one grade to the other. Remember, we can always take this a notch higher and even create other sophisticated things around it. Obviously, this will come in the subsequent sections on topics like functions, where combining now functions and the other say topics to be able to have this more sophisticated. At the same time, we can right away just add something here to have it just a little bit more, say, robust. We could say like, hey, maybe add recommendations in this case. So if someone gets a particular grade, then we can provide a specific recommendation for that person. Now we could just have that here, be above. Then that means that we're gonna just provide our recommendations, and this time we're gonna use dictionary in an application, right? So on our application, which is amazing because now we're gonna have recommendations like so, and then say something like, okay, as our key, and then we're gonna have our value here, then say something like excellent work, and then we're gonna have our B here, and then for B we're gonna say something like just good job here, and then now for C we're gonna have something like maybe doing okay. So let's have a comma here too, and then we can have something like for case D, and then we can say maybe you need work harder, and then for E, obviously we can say something like, hey, just some encouraging information, so that will be don't be discouraged. Maybe add something, focus on understanding better, focus on understanding. That's fully help, right? Yeah, so we need a comma here. So here you need to work harder, consider seeking for help. right? Uh, so yeah, so we can have all those particulars. So those are the recommendation, and now we're gonna see how we'll combine these recommendations with our if if else statement here. So we have that like so. Then that means that we're gonna use some of the interesting, say, dictionary implementations to be able to get all these specific values. So remember, if for instance we're gonna get and so this is gonna look something like this. So let me just comment this for a sec there, and then have us see this in action. Maybe say we want to print out the recommendation. So maybe print out a score recommendation and A grade. That will look something like recommendations, then dot get, and then we can have maybe say in this case want to get a case, you want to get A, right? So if you go ahead and run this, so it's going to tell you like, hey, recommendation for A grade should be excellent work. So in this case, in this instance, we want to just combine this recommendation with our if statements that we have for making decisions around different scores. So that will look something like this. So let's just uncomment this now that you've seen that. And then now just comment this and then have that referenced here. So we're gonna say, hey, your grade is, so we're gonna have the grade here considered. And now what should happen is that we should have recommendation too. So remember, we could just pick this like so, and then just utilize it here. So that means that we're gonna have this one here, and then say recommendation, and then we should be able to have recommendation. Your grade is, and then recommendation dot get, and then we wanna get the key, and then that means that for our key in this case, we're gonna just consider grade here, and then that should do it, right? Now we could test this and then see how that works for our case. So we could just try this. So we're gonna run it and then say maybe something like maybe have a different say score that will be maybe 70 for a case. That is gonna tell you like, hey, your grade is C, recommendation doing okay. Awesome. And that's what you're seeing here, right? So we come back here, something exactly like it's able to pick the specific corresponding value off of the key that I try to invoke. So amazing. So that's how we'd work around this. This is just a simplified version. I promise we're going to build up on this and then just have it a little bit sophisticated. But at this point, given that what we've covered up to now is branching in Python, we're just considering the topics that we've covered up to now and the ones that we've covered previously, that is. So we're going to build up on that and then kind of improve on these applications that we're working with. Now, let's get to the next application that we'll be working on. That is the weather app, and then see how we'd use the decision making of if else statements to be able to make decisions around specific weather. That is. Now let's jump to that. Now let's consider creating a second simplified application. Let me create a new file that will be weather outfit selector py. Now, what if your program could suggest what to wear based on the weather? So let's build a weather best outfit selector to see how this will look like. So that means that first thing first, we're gonna need to map out how the application should function or should behave. So in our case, then that means that we're gonna start with asking the weather, and then after asking the weather, then we should be able to say if enters to be sunny, then we should label to something like, hey, the person should be able to sunglasses and maybe light clothes. And then yeah, we're gonna introduce elif Then we're gonna say weather, or if someone enters rainy, we should be able to at least let this person know that um they'd be able to need an umbrella and even wear raincoat. So I'm sure you get the gist here. So that's how it'll look like until now we get to our else statement, whereby in this case, so else. So obviously this is where we're doing a termination, right? So we're gonna terminate here. Or rather we just terminate below else. So we're gonna say, hey, else we don't know the outfit suggestion. Okay, awesome. So given this detailed roadmap, let's kind of walk through it step by step. So asking for weather, again, we're gonna just use kind of how consider what we did in our previous application, student grading application. So we're gonna have hey, weather equals to, and then now for this case, we're gonna have input, and then ask what's the weather like today, and then maybe even provide choices. Sunny, rainy, then is it cold or something, right? Awesome. So we can have that. And then now we're going to start with the if statement. So we're going to say something like if weather is equals to sunny in this case. So we'd expect to display that wear sunglasses and light clothes. And then we have boys, you're gonna say hair leaf weather equals to rainy. So the person know that hey, take an umbrella, right? And then we could have another elif weather it's cold, then we're gonna say hey, wear a warm jacket and gloves. And then here, finally, we're gonna say hey else. So if it's otherwise, then we're gonna display sorry an outfit for that weather. Awesome. So let me just remove this too, then this one too. Awesome. Now we could try this out and then see how this would look like, right? So let's go ahead and now have Python. This should be weather. Outfit selector. Then it's gonna ask you what's the weather like today. Then I'm gonna say, hey, today is sunny. So I tell you, hey, wear glasses and light clothes, right? Wear glasses and light clothes. Awesome. Then obviously that means that if you'd have maybe a different one, maybe say cold, I'm gonna tell you, hey, wear warm jacket and a glass. So the script simply gives you clothing advice based on the weather, just like a smart weather assistant, right? So obviously a simplified version in this case. But remember, if anything, you can introduce other say implementations. So for case, for instance, if someone maybe say we provide maybe sunny, notice we're gonna get sorry I don't have an outfit suggestion. And in this case, what it says is since we have a lowercase sunny s in sunny, and it considers an uppercase s, then we're gonna have an issue with that. So in that case, you can improve that by saying something like lower. So lower is a string method, should lower the specific say text or a string text. So in this case, we're gonna have all those as lowercases. Now, if you run this, they just have everything as lowercase, maybe sunny like so. We won't have that issue anymore. Now, let's say someone kind of runs your program like so, and then maybe say the person considered maybe a different values. Maybe it's hot. Now, let's say a user tries to run your script, right? And then this time could have maybe say a value like it's hot. In this case, in this instance, then what's happening? You're getting an output like, sorry, I don't have an outfit suggestion for that weather. But in our case, we already know like, hey, something hot should be corresponding to sunny. That's where now we can get to improve this. And guess what? We're gonna be using similar concept that we used for student grading, that is introducing a dictionary here. So for case in our weather outfit, we're going to just try to introduce a dictionary to be able to do some mapping in this case. Now we can go ahead and create a weather synonym dictionary. So that will look something like this. So, and then we'd have hot, and then we'd have for case that should be considered as sunny, and then we'd have warm, then that should be sunny too. And then something like stormy, then that should be rainy. And then if we have something like drizzly, that should be considered as rainy too. If we have chilly, that should be considered as cold, obviously. Then if we have freezing, then that should be considered cold too. Now, if we also have foggy, that should be considered as cold too, right? So we can have those considered their synonym if we don't have, say, the specific values. In that case, I'm gonna have, let me, this one's in quotes. Awesome. Now, if we have that, then we have weather synonyms. So what you're trying to consider is that if someone inputs a key like hot, then should correspond to sunny, and then in that case should reference kind of something that is under sunny, that is wear sunglasses and light clothes. And if someone inputs something like chilly, that should correspond to cold, and in that case, then we should be able to get an output under cold weather condition, where warm jacket and gloves, right? So now we're gonna have this again, just similar to how we talked about it earlier, like the bit of say, let's comment this, then we can use some of the Python's dictionary methods to walk through this. So we can say print and then weather in synonym, and then that will be something like that. Then that means that we're gonna have weather synonyms dot get. And then obviously in our case it should be able to get the specific weather. So there'll be our key. Maybe if we go ahead and run this, then we're expecting an output like, hey, that's sunny, right? So that would be the value of that, right? Now that we have this, we could have this incorporated into our earlier created application. So we're gonna comment this and then see how we'd have this incorporated. So the dictionary that we have created now. So that means that we can easily have that under say the weather after someone inputting weather. So we can have maybe say dictionary. We can call the dictionary of create a variable for it. So normalized weather or something. And then for this case, we're gonna say like, hey, let's pick, let's just pick the weather synonyms, and then get our weather like so. So that will be the weather. It's gonna get the weather as a key like so. And then in this case, then if we run it, then have hot, we're not getting the output that we want. So let's see kind of what went wrong with this. Oh, got it. So where we went wrong is this part here, the weather, right? So if we're calling the weather here, and this one we're changing it as normalized weather, then that means that this aspect we're still calling weather, so it wouldn't consider that. So we're gonna just change this to normalized weather, so that that's featured too. So let's have all this here, like so. Just now, let's run it again and then see how what you're getting. So if you say hot, it's gonna tell you, hey, wear sunglasses and light clothes. So then we can say something like maybe run it again and then say drizzly. Then it's gonna tell you like, hey, take an umbrella and wear raincoat. Remember for drizzly, if you go back and see what he had for drizzly, its value is rainy. So it's gonna go ahead and consider the kind of the condition under rainy. That is take an umbrella and wear a raincoat. So that's how. Now, if you consider maybe say a foggy, let's just consider foggy and then see how that looks like. So that'll be foggy like so. And then tells you wear warm jacket and gloves. Now, interestingly, we try have sunny. Yeah, I'll tell you, sorry, you don't have an outfit suggestions for that weather. Now, the best way to work around this, and for the most part, is get around different say issues. So when working on different implementation, then you're gonna just kind of figure out how you'd be able to play around maybe with different methods. Also come up with different say implementations and see how that works. So in our case, if we go ahead and use Sunny, we're gonna have an issue. But now an interesting thing is that you can easily come here and search get method dictionary. And with the get method, you can use maybe you could just click double thresholds and then get to see how it's used. So remember, this is kind of some of the things that we talked about when you wanna pick a specific key or pick a specific value, then you want to provide the specific key that is, for instance, a model. And then we have other functionalities, which in this case, you get to see the syntax of the get method. So by you have the dictionary, then get key name and then value. So if we go ahead and see kind of the explanation of the key name, tells you like that's the required, the key name of the item you want to return the value from. And then the value, there should be the optional a value to return if the specified key does not exist. Default value, none, right? So that's interesting. It shows you an example of how to work around that, right? So get price, if it's not there, it's gonna default to 15. So that said, we could implement that in our application where we have get, just have weather. And then obviously that means that if it doesn't get a value here off of this, then it can default to this, to the second one, right? And that means that if you go ahead and run this, and then have sunny, you get wear sunglasses and light clothes. At the same time, if you have maybe something like cold, should be able to just reference that, wear a warm jacket and gloves. Awesome. So up to now, the other application that we wanted to just look at and how to play around with it and see how that will work. Now that we've applied Python's decision-making power in the aspect of creating student grading system and weather-based outfit selector, we can now take it to the next level by handling loops. So in the next session, we'll explore for and while loops to repeat actions efficiently and obviously combine loops with what we've learned so far. Awesome. Now, in this section, we're going to talk about loops in Python. Now, imagine you're at a park and you keep going on a ride over and over until you decide to stop. That's exactly how loops work in Python. Loops allows us to repeat actions automatically, so we don't have to write the same code again and again. Another thing to note is that we're going to look at this outline for in this section. So that means that we're going to start with what are loops, why do we need them, and then for loops, iterating through sequences, and something like while loops, whereby we need a condition for it to change. There's the breaking and continuing loops, whereby you're controlling the executions. And then there's the infinite loops, when loops obviously never stop. And then there's nested loops. Now here, this loop inside a loop. Now, again, to reiterate, when mentioning loops, you just consider a situation whereby we need to repeat a block of code multiple times. Now, instead of writing the same lines manually, we use loops to automate that. And that's the main work of the loop. The two main types of loops that we want to look at. So that will be for loops and obviously the while loops in our case. Now, for loop allows you to iterate through a sequence. And we're going to look at such examples in this context. The main thing, obviously, in that case, then that means that if you have an action for an item in a sequence, like a list or a string, then this is where now the for loop will come in handy. That said, a for loop repeats an action for every item in a sequence, like a string or a list. So, for instance, we could look at an example of maybe a list. So remember, if you're talking about sequence, you could just have it. You could consider also a list in that aspect, or even a tuple. And in our case, we're gonna say maybe something like sequence, or we could just have list values. So, and then have maybe 34, and then 100, like so. Those would be our values that we're considering. So if you have those as our values, then the other next step would be to iterate through these values, and that's where now the for loop will come in. So we're gonna say for I in list val, so that will be list val like so, and then we're gonna print out I, right? And then now for in this case, if we run this, we're gonna get the output having all the say iteration through all the output that we have, right? Now something else to understand is the bit of the structure of the for loop. Then what you notice is we have for, that's a keyword, and then in, there's an in operator, and then now a list val. For the bit of the list val, you're just considering the sequence or kind of our list values that we have. So, and then also I should be, in this case, I will be a temporary variable. So if I is a temporary variable, this is an interesting way to always confirm that, because if you just print I in this case, then you're gonna see like, hey, we're getting an output as 100 in this case, right? So that's what you're getting here. So if you maybe comment this, or have maybe something like hello, so you're gonna see like, hey, I will be the last value that you have for you in your list. So it won't pick each and every value, but the last value, meaning that all values are temporarily held using I. And then now, yeah, so for every value, it kind of updates to a new, say, a value that is. So the I will update to a new value. And that's what we mean by temporary. So it's gonna start with the I equals to 34, and then I equals to 76, I equals to 100, and then that's how um it'll be able to temporarily hold all this value. I'm sure there's something else that you can notice here, right? When you're printing something like hello, so this means that the block of code that executes doesn't have to actually be related to the items inside the sequence that we have earlier, right? So it doesn't have to be related. It's going to just print out all those kind of the sequence or the length of the sequence that you're looking at. So for our case, that is 3, or the length of our sequence here is 3. And yeah, so that's how it go about it. Now, also, you can iterate. Remember, this, at this point, you're just iterating through, say, a list. You can also iterate through a string. So iterating string. And in this case, what will happen is that each letter in the string is going to be printed out one by one. So maybe say, for instance, we'll have a letter in, and then maybe programming, like so. And then I'm going to say print a letter here. And now if you run this, it should be able to display each and every, say, letter one by one of the word programming that we have here, or the string programming. So that's how you iterate a string. So that means that you can easily pick each and every letter, rather, for a particular word or a string that you have. You just be able to consider that. That means that obviously you can have, say, a value like 56, and it will work just the same way. As long as you have it in quotes, then that should mean that you have a value as a string. So if you run this, then what should happen is that it's going to print that out 5, 6 separately. So that's something to also note. Now, that mentioned, that's how we iterate a string. So there are kind of different, say, ways you go from here in terms of after indexing the different, say, word or characters that you're looking at. So the different ways that you can go from here, maybe even combining or joining specific words that you'd like, or maybe splitting the words. We're going to look at that. But before that, we'd want to see how you can repeat action using now range, right? So we're going to use the range function to repeat action. And simply put, obviously for the range, then all this means that you're just generating values from one, say, from one point to another, or from the start to the end, maybe say from 0 to 4. And in such a case, then that means that you're looking at range between those values. And with the for loop, you can easily iterate through that. So you can say for I in range, and then you can say maybe have 5. So that will mean that if we go ahead and print I, so we should be able to get values from 0 to 5, and then, yes, print that out. So obviously, by default, it's going to consider that as 0, 5. At the same time, yeah, so if you have something like that, you should be able to print out our values as we'd like it, just as we had it before, 0, 1, 2, 3, 4. Now, at the same time, you could choose what to start with. You could maybe say, let's start with 2, and then that means that you should be able to start from 2. That is, so it's going to start from 2, 3, 4, like so. So there's something to consider when you're working with ranges and how to go. Now, obviously, for the range again, you should just be able to return a sequence of numbers in our case. Now, that's iterating through a string, a sequence. So obviously, for this sequence, then that means that this could change to a tuple, and it should just work. Now, also, we'd want to also consider, maybe say, if you're iterating through a dictionary. So kind of how will you go about that, right? So for a dictionary, want to remember kind of the main, say, methods or the main functionalities around manipulating a dictionary, and then use that. So for a case, that means that with the dictionary, we did learn about, maybe say, if you have a dict file dot maybe a dictionary values, maybe say have a dictionary here, maybe say something like curly brackets, and then say we have fruits like so, and then we're gonna say this case provide some fruits, so that will be mango, and then apple, like so. And then maybe you could have another, say, pages. And then I could have spinach, like so. And then, yeah, we could consider others, but let's consider these ones for now. When iterating through this, remember, what we learned is that if you don't want to pick the specific, say, keys, so you can go ahead and have maybe keys like so, is in the dictionary, like so, and that will be dict underscore val dot keys, right? So that should be the method that we'll be considering. And now if you run that, we're going to get our keys. That is, it's going to give you the keys only. That is the fruits and veggies. At the same time, you can change this to values, and then it should give you values in this case. So that will be the values. There's something like, yeah, mango, apple, and then kale, spinach. Those are the values that we're considering. And then at the same time, also, there's the items method that you could use. And then if you run that, it should give you all the items. That is the key fruits and the corresponding fruits, and then the veggies key and its corresponding value. That is kale and spinach is our list. So that's something to consider. Let's just change this to maybe something like a tuple. So at least kind of have those both featured, tuple and list. Now, given that idea, then if you're looping through the values, maybe say if you're looping through values, right? So maybe for val in dict var, that means that you don't want to consider the methods that we've talked about. So for our case, if you don't want to maybe just pick the keys only, that'll be keys, right? So I'm sure now you're getting an understanding of it, whereby now you can say print now val, right? So that'll be, yeah, so it should be able to give you all the values, right? So we could say dictionary values like so. Then now you can say val. So if you print this out, it should be able to give you loop through the dictionary values off of the keys provided. Oh my bad, if we pick keys, it's going to just pick our keys without considering our values at this point. But unless if you maybe change that to values, then it should be able to loop through the values provided. So that means that you have two square bracket, the first one and then the second one. So it's just looping through those, right, all together. So that's something to consider. Now, with the items, you could have the items too here, like so, but that means also you'd have the key, like so, and then that so obviously you're providing your key and your value at the same time. In this case, then means that you'd also want to have your key, like so, right? So we could say maybe dictionary key, and then provide your key and then the specific value. So let's see how that will look like. It's going to provide, say, the keys and the values. To make sure that that's pretty visible, we could just have another, say, string text here, say, dictionary value, like so, and then comma, and then see how that works. You can see title like, hey, this is the key fruits and then the value mango, apple, and then at the same time the key veggies and then the value carrots and spinach. Those are things that need to consider, but it's right into a dictionary, if anything. Now, let's look at the second type of loops. That should be the while loops. And a while loop keeps running as long as a condition is true. So obviously, then that means that it's going to repeat until a condition changes, right? So something to consider. Now, let's go ahead and see a simple implementation of a while loop. So we're going to initialize, say, our count variable with 0. and then have while keyword, and then notice first while, have while and then condition, and then under that you statement 1, under that you can have statement 2, like so. So this is the main structure of the while loop, how it work around it. So that means that if you're considering this structure, we're gonna have our count, and then we're gonna say, hey, if while count is less than 6, then print count, right? So that's what you're gonna kind of see. Obviously, if you have it like so, you should be able to print infinitely, right? So if you run this, then you're gonna see like, hey, it's gonna print infinitely, right? So the count is 0 all the time, which is less than 6. So this value is true. So it's gonna print out infinitely. So I'm gonna stop it manually. So let me do something like I do. Okay. Probably control C. There should be a keyboard interrupt. Control C, keyboard interrupt, to exit from a loop. Now we're gonna see other implementations. For instance, we did mention something like breaking and continuing loops that should control the execution. And we could use break or continue to be able to feature a stop instead of using the keyboard to interrupt the execution, that is, or an infinite loop. So we're gonna see that. Now, in our case, to make sure that we're not running into infinite loop, we're gonna make sure we're adding our counts here. So we're gonna say count plus equals to 1. And this essentially what that means is that it's saying, hey, our count, we're creating our variable count again. It should be count plus 1, like so. That means that when you're starting your loop, it's gonna start with the count initialized at 0, and then it's gonna you're gonna be adding one value to your count variable until this is no longer true, right? The condition that you have here. Now, to expand on this will look something like this. So you'd have your first, say, count. So at this point, you're considering 0. And then if you're considering 0, that means that 0 is less than 6. So we're going to print here 0, right? And then now there'll be 0 here. And then another new variable that is count should override the count again. So 0 plus 1, that will be 1 now. Our count is 1. So our next loop will consider our count as 1. If we're considering our count as 1, then that means that next time we're going to have 1 here. So 1 pass here. And then it's going to print out this time 1. And then now it's going to be now 1 here. There should be 1 plus 1. And then our count is updated to 2 now. Having updated to 2, then that means that our next loop will be 2. So we're going to be passing 2 again, 2. We're checking the condition again. Is 2 less than 6, which is true. So that means that it's going to print out 2. So remember, our first print was 0 and then 1. And then now we have 2 that we're considering to be printed out. And then if you have 2, 2 should just trickle down to this part. That is 2 plus 1, that is 3. And then the count should be updated to 3. And then that means that in our next loop, should be considering 3. And that will be something like this. So that means that we're checking is 3 less than 6. It is still less than 6. So then that means that we're going to print out 3 like so. If we're printing out 3, then that means that we're going to trickle down here 3. So 3 plus 1, we're going to have 3 plus 1 here. So that's 4. So we'd need to have our final printed value would be 5. So I'm gonna loop through all this, and then obviously at with 6, when you're trying to check for 6 here, at this point it's gonna stop at that point, since count, that is 6. 6 is less than 6, that's false. So it's gonna stop at that. And now, given the condition is not met, then it's gonna stop at that, and then we're about to put these as our values. So we can go ahead and see these values and then just compare to what we talked about in this case. So you're gonna see like here, kind of what we were mentioning, that is gonna have 0, 1, 2, 0, 1, 2 up to 5 as we had it before here. So as long as we understood how this works, the looping works, then it should be just as easy as such. Awesome. Now, beware, if you forget to update your count, this becomes an infinite loop automatically. All right, now that we know how loops work, let's talk about how we can control them. Say, for instance, a previous scenario that had, but we couldn't be able to stop the loop, that is, so we had an infinite loop. Or if you'd want to skip it specifically, that is on certain values, that's where now the loop control statements will come in. So the control statement will be around breaking. We're just discussing two of the main control statements that you'd want to use. That should be breaking and continuing. So let's have this down here. We can say loop statement. So now break should be able to stop a loop immediately, whereas continue should be able to skip the current iteration and moves to the next. So let's look at an example of this control system that we have. So that's here, and then you have B. So if we talk about breaking, then that will look something like this. Could have a for loop, or maybe later in Python. So, and then we can say if later equals to h, then break at that point. So what this says is, again, when using break statement, we'd need to exit a loop as soon as we find what you're looking for. For instance, for our case, what you're looking for is h, and that's why we have break here. So break should come in to have exit at that particular point if we find, after finding the h. So if we go ahead and now print this out, so we're gonna see how this looks like. So we're gonna say print and then current letter, then like so, then have the letter, so print it out. Then we're gonna see how this looks like, right? So if we run this, there should be Python loops. Then we're gonna get an error. Just as Python is not defined, so that means that it's taking it up as a variable, but we need to have it as a string data type, like so. So we wanna just have quotes, and then that should be it. So now we can see we're getting our values here, right? The current letter is P, the current letter is Y, the current letter is T. And that essentially just tells us like, hey, it will go ahead to print PYT, and then when it finds H, it's gonna break, that is, stop at that point. So stop the loop. So obviously that tells us like nothing after H is printed out. Now, that tells you like, hey, when did you want to use a break? That is when searching for an item in a list. And then for case our item, or we're searching up to H. If we find H, it should stop at that point. And then exiting a loop early or stopping an infinite loop, right? So maybe let's look at an example of a while, how that would look like. Oh, in this scenario, we could just improve on what we have before here. So we have the count. So we could have it here. And then now instead of the condition here, we could say while true. So while true, that means that where the true is should take the condition part. And that means that our condition will always be true. And that means that it should loop like forever. And in this instance, that's where now we're gonna implement the bit of say breaking and then see how this will work. So now we could have our break just below this and then say something like if count is greater than or equals to 5. Correct. So essentially this should just stop when the count reaches 5, right? So if we go ahead and run this, then you'll be able to see like, hey, when the count reaches 5, then it's gonna stop at that point, right? Obviously, then that means that it's gonna have the data points length of 5, that is. So obviously starting from 0 to 4, which obviously that should be 5 values. That means that obviously if you don't want to also just stop at maybe say something like 10 or maybe 8, that should take effect. So that means that we're gonna have it stop it at 7 since we're starting with 0. Now, what if we want to skip a specific value but continue looping? That's where continue helps. So we're gonna take this up, what we had here for our for loop example, and then have it here. So let's say instead of break, we have continue. That just says that hey, skip H, but continue, skip H and continue with the loop. So that's essentially what this is saying. We might as well have this run and then see how we'll be getting the output. So if we run this, awesome. So what you're seeing is we will start with B, Y, T, skip H, continue, O with O, and then end, right? So that's the continue bit in this aspect. So obviously for continue, then what you're saying is you can use it for skipping certain values in a loop or ignoring specific data and then moving to the next iteration quickly. Now let's also look at an example using the while loop. So for case, I'll pick this and then we're gonna have it down here. And then maybe say for case here, we could say we could skip even numbers. So we're gonna say continue this point, and then that means that we're gonna use a modulus to calculate the even number. So that means that we're gonna have something like count modulus 2, then equals 0, right? So that means that if we're checking for even numbers, if we find 1, we're gonna continue or skip the even number. So in this case, that means that we're gonna say skip numbers. So and then we'll say maybe for instance, I'll go ahead and print now our numbers. So we're gonna say print count, and then comment on this, and then run it. You got the idea, right? So gonna run like so until we have interrupt. for the same. So in this case, then it would be dangerous to have while true just as is. We could just have what he had earlier. So that means that we're gonna just pick this. Then come here, have it here. So kind of at least we have a cup for the same. A cup that we're considering, right? Let's try run it again. Gonna comment here. Yeah, right here. Okay, seems like it's not working anymore, but could try maybe let's just comment this, then have it print our output here. So we're gonna say print count. In that case, obviously, that means that it should be able to skip even numbers. And then we're gonna have something like, well, it seems like commenting it at this point is not working. So we could just have print and then count like so, and then try run this again. Okay, so and then maybe we could introduce count equals to 0, and let's have this working. Awesome. So kind of notice the output, like you have 1, 3, 5. So it's gonna be skipping even numbers and then outputting the odd numbers given the count that is we have. So if it's an even number, it's gonna skip that and then continue the program. Let's say you wanna have a loop inside another loop. That's where the nested loop comes in. So for this particular case, we're looking at one loop inside another loop. So for this particular case, we can look at maybe even looping through numbers, and that means that we're gonna display pair numbers. So that will look something like for I in range 5, and then for J in range 3, or could have it as also 5, have it uniform, and then you can go ahead and print both of them. So I, J, and then have us run this. So you're gonna have all these kind of the pair output, whereby for each I that we have, the inner loop runs completely for every J. That will look something like for each I. So I will be the left side, right? So the zeros here, and then for each I value, we're gonna have a complete run of J. So with all the values that is that we're considering. And then at the same time, we're looking at this to, yeah, this can come in handy to help create patterns and grids and even work with matrices and tables. To do a quick recap of what we learned, we started off with what are loops, and we say that when you need to repeat a block of code multiple times, then we'd have loops come in, whereby it's gonna be help write. And we mentioned that when we need to write a block of codes that is repeating, that's where now the loops come in. We talked about for loops, and in this case, we talked about this in iterating through a sequence mostly. So that means that you can iterate through a list, string, a dictionary, a range, most especially. Now, after that, we also talked about, say, something like the while loops. And this is best for looping until a condition changes. That's what we figured out. And then after that, we did talk about loop control statements, whereby in this case, we talked about two types of control statements that we're looking at. That's the break and continue, which control the loop execution. So for break here, we mentioned that it stops a loop immediately, and then for continue, it skips current iteration and moves to the next. And before the nested loops, we talked about also the infinite loops, whereby can be just achieved by having while true and then running something, maybe print. So that will be infinite loop because it's gonna loop forever. And then finally had say the nested loops, whereby we're looking at looping inside loops for complex tasks. Now that you've mastered loops, get ready for the next session, handling functions in Python and how functional programming comes about in Python.